Um, so I'm going to show some stuff from our introductory course to geology, the practical part, which is exercises and excursions, field trips. And as everyone else, we've had to solve this digitally since we can't go to the field. And as part of that, we made some movies as a digital field trip. We have different parts of the course, and I'm responsible for the sort of hard rock inside of the earth type part of the course, whereas Jostein is responsible for the more surface, glacial, climatic, surface processes part of the course. So we're making films from everything, but so far the stuff that I cover is ready, and the rest is being edited. So what I'm showing today is mainly from my part of the course. So when we started to put this together, I mean, the learning goals for this course are directed towards giving the students conceptual understanding of geological processes, methods, using their own observations to explain the geology around them, and so forth. So we started putting together the course using a lot of digital resources from around the world, and that's fine. You can use a lot of that to address the more fundamental aspects of the learning goals, and I'll show you some of that as well. But then we realized that by just using examples from around the world, like Australia and the UK, they're missing out on one important bit, which is, you know, they should learn something about the geology in their own backyard, so the geology of Western Norway. So for them not to miss that, we made a digital version of the field trip that we go on here in south of Bergen. But I'll start by showing you some of the stuff that we put together for this course. I'll first show you some of the digital resources that we've used online, and then I'll show you some stuff from the virtual field trip, so from the film that we've made. So I'll just share my screen now. Can you see my screen, Jostein?
Yeah, we can see it.
You can see the screen. Okay.
Yeah.
So basically, there's a virtual excursion of FIA course, and this is in Norwegian, and the movie is in Norwegian as well, but that's fine. So I'll start with this first bit is questions related to the movies. I'll skip that for now, but some of the things that we cover in this course is, you know, how to use the principles for determining relative age and so on. And how do you solve that when you cannot go to the field? Well, there are multiple resources online with virtual outcrops, and here we use a place called Bingy Point in New South Wales, Australia, to work on cross-cutting relationships to work out a geological history. And if we go to that, if we go to this database here, which is called eRock, there is a series of outcrops that we can use, and this is the Bingy locality, and I've opened it here, and as you can see, we can navigate around here and take a look at the outcrop. And as you'll see here, there are a series of intrusions. These are dikes that we can see right here, and there are even stops here. You can see mafic dike, cross-cutting felsic dike, and so on. And we can navigate over here, and we can take a look at other stuff that's in here. It's a dacite dike, and we can look at what's over here, which is a dolerite dike, and they can basically navigate around here and take a look at, you know, what's here, and then they can solve these. They can actually use these observations to answer these questions. They'll make a sketch of the locality as they would in the field, make a short description of the geology of the area, what kind of rocks they are, and so on, describe the rocks, explain a few terms, and then they will use other resources for their rock descriptions. So I've directed them towards the UK virtual microscope that we'll take a look at in a while. And then the tasks are to basically talk about, well, to basically use the observations in the model to explain the age relationship between the mafic and felsic dikes that we can see here, navigate to the different localities? Can you determine the relative age relationship between dolerite, diorite, dacite, and tonalite based on the observations here? What kind of age relationships can you say something certain about? What can you not say something certain about? And then based on the observations in the model, describe the geological history of this area as much as the observations allow. Then we have another database that we use is Arches Road Cut in Utah. Then we go to another database called V3Geo, which is also full of virtual outcrop models that can be used. And we can then go start this in full screen viewer. And as you can see here, this is an outcrop where we can see a series of faults, a series of normal faults. And then we use this outcrop. The students can navigate around it. They can use a measurement tool over here to make measurements. And they then start out making a sketch again. They use the measuring tool to make a scale, make a description. What kind of faults are these? What's the geometry like? Do they look like the textbook? Well, then they might not. And then they're tasked with measuring throw and making a table of throw measurements, and to determine the age relationship, the relative age relationship between the rocks and the faults, and so on, and then some questions. So basically using these digital online resources to describe, to observe faults, to measure them, and so on. And then we have another thing that we cover in this course is how to find the right way up in a sedimentary rock. What is the stratigraphic right way up? And also rock descriptions. And I mentioned the UK virtual microscope. So in terms of doing rock descriptions, it's kind of hard when you can't go to the field. But here they're going to make a few rock descriptions of a few different rocks that are quite similar to the ones that we encounter on the virtual field trip here in Norway. And I've asked them to describe a basalt, a granodiorite, a conglomerate, and a gneiss. And then I direct them towards the UK virtual microscope, which we can find here, which is a great resource. And we can see here, if we click explore, we can see the different rock samples are quite UK dominated. If we go back to the collections, we can see there are a series of different collections. UK virtual microscope is just one of them. But if I, for example, go to the basalt that they're going to describe, they can view a 3D view of the hand sample. They can rotate the hand sample and observe it from many different sides and describe the rock as they see it. They can also go back to the to here. They can go and look at the rock in thin section as well. And here they can choose to view it in PPL or in XPL, and they can do this for different kinds of rocks. So we can, for example, look at this rock here, PPL and XPL. So that's a great resource to look at the hand samples and thin section images. And then we move on to put in, to look at stratigraphic the right way up. And one of the videos that we've made is about determining the right way up. They can look at that, and then they can look at these images, and based on these crossbeds, they will determine what is the right way up in these different rocks here. So you have a few different images which should be relatively simple to determine stratigraphic right way up. So that's also part of the of the exercise. So this is similar kind of stuff that they would do in the field, but they now do based on these online resources. Then obviously they also need to understand geological and topographical maps, and here is another great resource. Use the virtual landscape model and answer these tasks. So then we can go and look at another resource from the University of Leeds. So basically, if we look at this model here, we can see it as a topographic map and a DM. Basically, we can see there are høydekoter. So basically, these lines here tell you the altitude, of course, and then you have a geology that you can The fine thing here, the nice thing here is you can actually rotate the geology. So if I push the buttons 1 to 3, 1 to 6, you can see the dip of the beds are changing. So they can use that to play around with and see how the orientation of the layers intersects with the topography, to try and understand a bit more about how the interaction between the geology and the landscape is working. And then they're tasked with pushing the button 4, which gives this dip right here, and then to make a geological profile along this little valley here, as we can see along this line here. And then they're also sent into the field to do a bit of independent field work to measure strikes and dips and so on. So that we have a video showing how to measure strike and dip, and they're sent out in the environment around them to measure strikes and dips. And we also send them out into Isdal near Bergen. We give them a topographical map and geological map, and they then have to go out and make a few stops in the different rocks, and keep a field diary, and as you would in the use your field book, make good field notes, make measurements and so on. This they can do independently or in small groups of 2 or 3, as long as they, obey the rules or recommendations of the health authorities and keeping the distance and so on. For those who are not in Bergen, they can select an area around them, and that's described here. So this is similar to what Jostein has created for his part of the course, where, so let's see if I can find that. That's down here. So basically, to go out, find examples of different soils, and use localities around them to basically formulate hypotheses, and to describe quaternary geological localities around Bergen or wherever they might be at the moment. So basically, we use a combination of online digital resources, sending them out into the field and do independent data collection by themselves, fairly simple stuff. And then there is these videos that I'm going to show you. So I said that, we wanted to include this because these videos, because we didn't want them to miss out on this bit that has to do with the local geology as well. So now I'll show you some of that, some of the videos that we made, and we made them with a local Bergen company called Brick. And so basically, I'll show you little parts of this movie to demonstrate, how it works. As you can see here, you can navigate through the movie in different chapters, and we basically go through. We talk about the Caledonian orogeny and how that has imprinted on the geology of Western Norway, and we go through. We talk about the Iaptus Ocean, which was there before it closed and the whole thing collided, and we had the orogeny forming, and so on. So I'll just show you a few different clips. This is the beginning of the movie. So I hope this works with sound and everything.
Hjertelig velkommen til Feldkurs GOV 102. Etter å ha lært mye om teori og ting og tang som man må kunne geologi, innendørs på realfabriket så skal vi nå ut, og vi skal lære om Vestlandets geologi, om hvordan alt ble til, hele den spennende historien som gjør at ting ser ut sånn som de gjør I dag.
So can you guys hear the sound and see the picture all right?
Yeah, it's good.
Yep. Okay, good. So basically, we start here with an overview of Bergen, and we take out a geological profile, a principal diagram of what it looked like before the Caledonian orogeny, and talk about that before we. So I'll just skip down to where we look at the profile and talk about where we're going to go today.
Det vi skal gjøre her I dag, vi skal reise til forskjellige steder I dette gamle bildet her. Vi skal se på havbunnskorpe, vi skal se på øybuebergarter, og vi skal se på de sedimentære systemene, altså sedimentære bergarter avsatt på marginen av Laurentia. Okay,
so basically, we're talking about where we're going to go today. We're going to go and see the ancient oceanic crust. We're going to go and see the sedimentary systems that were deposited on the Laurentian margin before the collision, and we're going to see the island arc rocks of the island arc that was in the Aptus Ocean. So at the end of this sort of introduction here, we then take off to our first stop, which is to look at the ophiolites from the old oceanic crust in the Aptus Ocean.
Fra geologien her på Vestlandet. Da stikker vi.
So now we're headed to the ophiolite.
Da vi kommet, da vi kjørt fra Bergen, der vi var I sted, og opp til Søfteland. Og vi har foretatt en tidsreise. Vi har beveget oss rundt 450 millioner år tilbake I tid. Og vi midt I Japetushavet. Og det vi ser bak oss her, det havbunnsskorpen som var I Japetushavet mellom Norge og Grønland, eller mellom Baltika og Laurentia på den tiden. Og jeg nevnte dette at vi hadde
So here we're looking at we're going to look here at the ophiolites. That's our first stop. We'll then go and look at some of the details and make some detailed observations in there. And then I'll skip right down to our next stop, which is to look at the depositional systems and the sedimentary rocks from those depositional systems that were active on the Laurentian margin before the collision. So that's down at Ulven. So let's just go and look at that. Vi har snakket om at dette etter hvert utviklet seg til en kollisjon, men som sagt, før denne tiden så lå det et stort hav imellom. Vi har akkurat vært og sett på den havbunnsskorpen på Søfteland. Nå skal vi videre til Ulven. Da skal vi til marginen av Laurentia. Da skal vi se hva vi finner der. Av de tingene som ble avsatt, der hav møter land. Okay. Nå vi altså kommet til Ulven, og her, foran oss her, så ser vi plutselig noe helt annet. Og vi har jo lært om 3 ulike typer bergarter vi har. Vi har magmatiske bergarter, vi har sedimentære bergarter og metamorfe bergarter. Og da kan vi jo prøve å gjette litt, altså hvilken type bergart dette her, hvis jeg ser på dette som ligger foran meg her nå. Det altså sedimentære bergarter, og det vi ser her vekslende sandstein, som her borte, konglomerat, og igjen sandstein. Og det So here we basically will spend time looking at the details of the sandstones and the conglomerates. We'll talk about how to find the right way up and all that stuff. And once we've been here looking at the sedimentary rocks at Ulven, which was the sedimentary systems active on the Laurentian margin, we'll then move on to look at the island arc rocks. So the first thing we'll look at is the rocks that were forming at depth, so the intrusive rocks under the island arc, which forms the Sunnhordland batholith. So we'll go and take a look at that. Okay.
Har vi funnet den subduksjonszonen som var ute i Apetushavet, som vi snakket om tidligere i dag. Så da skal vi gå og se her borte hva vi ser av disse intrusivbergartene i Sunnhordlandspatolitten. Nå har vi jo sett på sedimentære bergarter i dag. Det vi skal se på nå, det er magmatiske bergarter, nærmere bestemt intrusive bergarter. Altså bergarter som har intrudert, trengt seg inn i skorpen og størknet der, uten å komme ut på overflaten. Og da skal vi bort se på hva vi har her. Vi er som sagt i...
So then we go through a series of detailed observations, and we look at cross-cutting relationships and the principles of inclusions and having xenoliths in melts and stuff like that. And then I'll just skip through to the summary here, where we summarize those observations.
Som altså er yngre. Og så er det en ting til da, og det er at hvis vi ser her nå, så ser vi det at i tillegg til alt det vi har snakket om, så har vi sånne lyse ganger som går igjennom, det kutter tvers igjennom både disse lysegrå og også disse mørkere fragmentene av dioritt og gabbro. Vi ser at disse lyse gangene, de kutter igjennom alt. Og dermed, hvis de kutter igjennom alt, så er de nødvendigvis yngre enn alt dette andre. Og disse lyse gangene, de er da av granitt, som er en felsisk intrusiv bergart, altså en veldig lys intrusiv bergart. Så da kan vi på en måte si at gabbroen og dioritten, det er det eldste som er her. Så kommer da altså granodioritten, fordi at disse eldre gabbroene og diorittene, de ligger inni den. Men det yngste er altså da disse gangene som kutter igjennom alt. De kutter igjennom både den lysegrå granodioritten, og de kutter igjennom de mørke gabbro- og diorittfragmentene. Så denne lyse granittgangen er yngre enn alle de andre.
So basically, to lead up to this, we've taken them through each of these observations, and we basically end up concluding the sequence of events here. But then we leave one part of the mystery sort of to the end of this stop. And if you notice, there was one problem that was left here. There's a bit of a sort of a surprise element.
Sprøstrukturen her er yngre enn alt det andre vi har sett på her.
And that's coming out.
Men da har vi egentlig klart å gå til bilen igjen, bortsett fra en ting. Og det er nemlig det at, altså det vi så på her, vi sa det at vi hadde granodioritten som var yngre enn dioritten og gabbroen. Så vi sa at dioritt og gabbro, det var de eldste, men vi klarte ikke her å finne noen observasjoner som kunne gjøre oss i stand til å si hvilke som kom først og sist av gabbro og dioritt. De bare fantes som kantete fragmenter inne i granodioritten. Så hva som kommer først og sist av de to eldste, gabbro eller dioritt, det har vi ingen observasjoner som kan si oss noe om her, men det har vi et annet sted like borti veien her. Så før vi kjører til Stord og vulkanitter på Kattaken, skal vi bare ta og løse det siste spørsmålet på vei ut av ekstraen. Da er det altså, her kommer en bil også. Så da er det rett og slett bare å karre seg opp her. Her ser vi et sånt mørkt fragment som er gabbro. Og så ser vi det at den er intrudert av en sånn spettete dioritt. Og når dioritten har trengt igjennom eller intrudert og kutter igjennom gabbroen, da må dioritten være yngst. Fordi at gabbroen måtte være der før han ble kuttet igjennom av en dioritt. Så altså, gabbro er eldst, og så kommer dioritten, og det er akkurat sånn som Barents reaksjonsserie forutsa. Men her har vi altså beviset.
Og så drar vi da videre til Kattnakken, der vi skal se på vulkanittene.
Kattnakken neste. kommet til Stord og til Katnakken. Og det som vi så nede på Reksteren, Sunnhordlandsbatolitten, nå skal vi se på det som lå oppe i dagen i disse øybuene. Og bak oss her ute så har vi noe som kalles for stovgolvet. Der det fylitt og alt mulig annet rusk og rask. Og over oss her så har vi da Katnakken, som en serie av vulkanske, altså ekstrusive bergarter, som ble sprutet ut i form av lavastrømmer og pyroklastiske strømmer når vi hadde denne øybuen ute i Apertushavet.
Okay, so what we'll do here is then we basically walk through this succession of volcanics, and I'll just there is like one stop that is a key locality to understanding the whole thing, and I'll just show you that before I'll show you the final stop, to sort of how we try and draw the students into making these observations, even though it's actually only on film.
Ok, så her vi nå kommet inn i noe litt annet. Og dette litt kult, for dette en nøkkellokalitet til å forstå hele Katnakken. Så kommer vi bort her nå, skal vi se. Så ser oppe på denne platen her, så ser du det at vi har ser du disse grå sakene her. Sånne små grå, nærmest linsaktige former. Vi ser det at denne grå saken her, den på en måte blir tynnere her og forsvinner. Og litt i andre enden så blir den på en måte til to sånne ender. Den deles opp i to ender. Så kommer det en større enn her. Så kommer det en enda større enn her. Og her nede det en ganske stor en. Og det litt interessant. Og dette her, som vi ser her på nå, det noe som kalles for fjammestrukturer. Så det altså noe som vi finner i en ignimbritt. Og en ignimbritt, det da en avsetning på en pyroklastisk strøm.
So then we'll use those ignimbrites or those fiamme structures to actually determine what is the right way up. And that is supposed to be a bit of an aha moment for the students, which is always in the field. And we're trying to recreate that aha moment here in the movie by using,
Absolutt. Og da får vi disse flate, avlange fjammestrukturene. Og det som litt interessant med disse fjammestrukturene at de kan fortelle oss hva som rett vei opp i en pyroklassisk strøm. Og sånne fjammestrukturer, de reversgradert. Det betyr at de minste ligger nederst, og så blir de større etter hvert som de går oppover. Men hvis vi ser her, så ser vi det at det motsatte tilfellet. Her ligger de minste øverst, og så blir de større etter hvert som de går nedover her. Og hva betyr det? Det betyr jo da at hele skiten snudd på hodet. Hele Katnakken og de vulkanske bergartene vi ser her snudd på hodet. Så det betyr at det yngste her ikke ligger øverst i toppen av Katnakken, sånn som det vanligvis Dette snudd opp ned, så det yngste finner vi nederst der som vi begynte, der som vi snakket om rhyolitisk glass.
Yep, and after this little aha moment, we continue to the top, and we've walked through rhyolites and all sorts of stuff, and we end up in the basalts on the top, and right at the end here, sorry, I'm just gonna navigate to the right stop. Where we basically summarize things.
Jeg begynner å grine. Okay, så det vi egentlig har sett her jo bare en spektakulær historie egentlig. Altså i går så var vi da nede i Sunnhordlandsbatolitten, som på en måte det som foregår nede i skorpen når vi får dannet et øybuekompleks. Vi har den nedadgående platen som begynner å smelte, så trenger smeltene opp i skorpen som ligger over og lager et stort intensivt kompleks som heter en batolitt, og på toppen av dette her så har vi vulkanene som den vulkanske øybuen. Det det vi har sett på i dag. Så vi har på en måte både sett det som foregår i dypet, som vi gjorde i går, der det var grovkornede, intrusive bergarter, og vi har sett alle disse bergartene som har blitt ekstrudert, altså kommet ut i utbrudd på overflaten. Det det vi har gått igjennom i dag, og de mye mer finkornet, de har størknet mye raskere. Men det som utrolig kult, jo det at alt dette opp ned. At det så vi lenger nede. Hele greien opp ned. Så mens alt dette dannet på en måte i det platetektoniske miljøet som en vulkansk øybue, så det ikke den vulkanske øybuen i seg selv som har bare snudd seg selv opp ned. Det skjedde jo da i selve kollisjonen. Så når øybuen kolliderte med Baltika, eller når da Grønland eller Laurentia kom seilende, på et eller annet tidspunkt inni der, så ble alt dette her invertert og ligger sånn som vi gjør i dag. Så det jo en helt syk historie egentlig. Da kan vi stikke ned igjen, og så kan vi kikke litt mer på figurer og kart som vi kommer ned igjen til bilen.
Yeah, so that was what I wanted to show you, and basically the students they solve they answer questions related to the movie, and they have questions that are more reflective about basically that relate to the movie. But essentially, the combination of these online resources, some independent field work, and this virtual field trip in form of this movie, and the movies that Jon Inge and Jostein have made are now the sort of total package of what we normally teach in the field. So the feedback from the students so far has been very good, and we'll run a survey at the end of it to get a bit more insight into how they actually respond to this. So that's it.